So I'm Chip Childers. I'm the Chief Technology Officer for the Cloud Foundry Foundation. The Cloud Foundry Foundation is the home of the open source cloud native application platform, which is called Cloud Foundry. It's an open source initiative. It's built jointly by a large number of our members. We have over 63 participating member companies and quite a lot of community collaboration as well to create the software. The software is commercialized by a number of vendors, specifically Pivotal with Pivotal Cloud Foundry, IBM with the IBM Bluemix platform. SAP has recently done a number of announcements around the SAP Cloud Platform. Their next generation version is based on Cloud Foundry as well. And there's a few other regional providers, companies like Swisscom or Fujitsu or NTT Communication are all offering online PaaS-style services using the Cloud Foundry software.
And so you described kind of what it is at a high level, but what actually does it allow these providers to provide, and what can people do with it? What can users and developers and platform people do with it?
Sure. Yeah. So Cloud Foundry is a platform that's all about how do you make application development and deployment as well as operations as simple as possible. Its experience is, for a developer, one where you simply write your code and then you hand that code to the platform. It takes care of all the things like creating containers for you, provisioning those containers within an infrastructure, instrumenting the deployed application for log telemetry, providing metrics into it, and then it also just makes it very, very simple for rolling out new versions of the software. There are lots of different patterns that people use for that. Things like canary node deployment or blue-green deployment models. All those are very, very easy to do with Cloud Foundry. So our whole focus of the system is to find ways to help the enterprise developer focus on the business application that they're trying to write.
Okay, so what are some of the component parts of Cloud Foundry? Look, what's the component parts under the hood that comprise the platform?
Sure. We can really summarize it by describing two different layers. One of them is Cloud Foundry Bosch, and that's the operational experience. It's what whoever's going to deploy a Cloud Foundry cluster is going to use for deploying that cluster, deploying various backing services, things like databases, message queues, etc. So it really operates as a distributed systems release engineering tool. Now that sounds like a mouthful, but it's actually a very, very important combination of configuration management of the platform. It does infrastructure agnostic deployment, but it also interacts with a large number of both public cloud providers as well as on-prem infrastructure software, things like VMware's vSphere or Photon. Works well with OpenStack, and it could even deploy using some of the bare metal provisioning systems that are out there. So that's the Bosch layer. Above that is the developer experience, and that's the Cloud Foundry Elastic Runtime. And that's the experience that I was describing. It's very focused on how a developer just pushes its code in, how it then builds containers and all the great things that I described previously. Each one of those two layers has all kinds of different pieces and parts that make it happen effectively. At the Bosch layer, it's perhaps simpler to describe. There's a key component called the Bosch Director. The Bosch Director is responsible for taking commands from the operator and specifically taking combinations of things. One is what's called a release manifest, and the other is a deployment manifest. Release manifest is the description of various system jobs that are going to be performed by various virtual machines or physical hardware that's going to be part of the environment. And then the deployment manifest is the specifics about which releases you want to deploy into what size virtual machines and what the networking configuration will look like, that type of thing. At the Elastic Runtime layer, there's even more to it. We have the components like our UAA module, that's Universal Authentication and Authorization. So it's responsible for protecting the platform components themselves, for authorizing and authenticating the developers that are pushing applications. Then we have what's called the Cloud Controller. This is the API surface area that a developer can interact with if they want to talk to the platform directly. It's what our CLI tools talk to. It's really the kind of the front door for the developer. And you can think of UA as the lock on that door. When an application is pushed in, it goes through the Cloud Controller, and the Cloud Controller talks to then what's really the kind of the scheduling layer of the whole system. And this is where we have what's called the Diego scheduler. The Diego scheduler is responsible for coordinating the larger part of the system, right? It's the actual cluster of hosts that are going to run the various containers that have been built from the software that's been pushed in. If we dig in a little bit deeper to what's happening inside of Diego, of course, there's a number of control plane components there and involved, both tracking desired state, running what are called auctions. The auctions allow the various nodes in the cluster to shout if they think they can take responsibility for a particular job that's being requested. But in those cells, that's where we have a layer that's called Garden. Now, Garden is the evolution of the Cloud Foundry container technology. Cloud Foundry was using containers, Linux container features specifically, right? Namespaces, C groups. These features of the Linux kernel that have existed for a long time. We've actually been using containers as a core part of the platform for longer than even Docker has existed.
Oh, I know, they're not a new concept. Yeah.
Yeah, no, it's definitely not a new concept. Although, so at the Garden layer, we were very happy to be, besides Docker themselves, who donated the library Run C to the Open Container Initiative, Cloud Foundry jumped on that as a really good library that we could use to no longer have to maintain that real low level kernel interface. So we have different potential backing implementations of the Garden API. For Linux, though, we've fully adopted Run C, so now it's called Garden Run C. Now that's replacing what was called Garden Linux. Garden Linux being our own implementation of that lower level library. But that same Garden API is really useful because we support not just Linux hosts, but also Microsoft Windows hosts. Now,
is that that's a recent development, or that's been around for a long time?
It's been around it's been in production use cases for probably about a year at this point. We've got an approach that we take with Windows hosts pre the Windows 2016 software. So pre-2016, Windows didn't actually support containerization, but we inherited some great work that had been done by Jared Ray, who was building a PaaS based on Cloud Foundry, but he was very focused on the Windows side of things. So we had inherited this thing called Iron Foundry. We bake that into the upstream, and it provides a series of techniques that allow the pre-Windows 2016 Windows hosts to approach the level of isolation that you get from actual containers. So implementing different things like registry access controls, spinning up different versions of IAS for the various websites that might be hosted. But we're very excited about the Windows 2016 container technologies because Microsoft has responded well to what's been happening in the Linux market, in particular around Docker and some of those specific APIs. And they've baked that into the Windows operating system itself. So we're looking forward to being able to evolve our Windows implementation to match some of the capabilities of the new Microsoft OS as well.
I mean, this actually seems to be an interesting conversation in itself, which maybe I'll revisit in a minute. But I just wondered, like, what was the origin story? Was it like a proprietary product that then got donated to Linux Foundation, or was it always an open source project that just had some key players and key proponents, or what was the order that kind of Cloud Foundry appeared in?
Sure. So Cloud Foundry, the platform was created at VMware. It was created, I think it was back in 2011. I may be incorrect about that exact year. I'm forgetting off the top of my head here, but it was created in VMware. And what VMware wanted to do was they realized there was a need for a much more application-centric platform. Now, if you track companies like VMware, you would know that Pivotal software was created through a number of different software assets and teams that were spun out of both VMware and EMC. So EMC had acquired Pivotal Labs, which is the agile development shop. They also owned Greenplum, big data applications. And then over in VMware, they had Cloud Foundry, but they also had SpringSource. So a number of these various software assets as well as teams were spun out into a new company called Pivotal Software. Now, Pivotal Software open sourced Cloud Foundry. And in doing so, they started to attract a number of, let's say, market competitors that wanted to offer Cloud Foundry software as a distribution or as a service. They started to participate in the development, and eventually it made sense for Pivotal to open up the governance of the project and mostly to invite more investment from their competitors, right? This is a pretty common story where something starts as single vendor open source. It might even start as proprietary before it's open sourced, but eventually, as it gets adopted, it's both in terms of the user community as well as the various vendors that are commercializing as downstreams. There comes a point where there's a desire to move it to an independent foundation. So the Cloud Foundry Foundation was announced back in 2014 as a series of letters of intent from a number of different large tech companies that wanted to partner with Pivotal. But in January of 2015, it became its own legal entity, and all of the intellectual property was transferred from Pivotal to this foundation. We are a collaborative project of the Linux Foundation. However, one thing that does make the Cloud Foundry Foundation unique is that it's a separate legal entity, so it's a separate corporation, whereas a lot of the collaborative projects of the Linux Foundation are really what are called directed funds, right? Everything's owned by the Linux Foundation. In this case, there's a separate company who works with the Linux Foundation for supporting it, both in terms of the marketing functionality that the Linux Foundation has, as well as a lot of the best practices that the LF has for large-scale shared R&D projects.
And I mean, was there any particular reason that it became that sort of setup as opposed to an Apache project or something like that? Was there any reasoning, or just something that happened, or?
Yeah. Well, sure. I mean, the one thing I'll say is that there are. I'm a member of the ASF, so I'm very familiar with the way that organization operates. One thing to keep in mind is that there's a large variety of governance models that are available to open source projects, especially if even if we just zoom in and say within independent foundations, right? There's a large variety of different governance models that can be put in place. At the ASF, the focus is 100% on purely the technology collaboration. With the Linux Foundation collaborative projects, there's an understanding that perhaps there's more to this than just the code itself. And so we really look at ourselves within Cloud Foundry as being focused on helping not only ensure that there's a level playing field for contribution to the project on a technical basis, but also that there's shared marketing that's occurring, so the different vendors can pool their people, their thoughts, their ideas, and their money, right, to do some shared marketing of the Cloud Foundry platform.
Okay. That makes sense. Okay, cool. I just sort of wondered if I look down the sort of major commercialized versions of Cloud Foundry, the ones that I know anyway, most of all would be IBM Bluemix, HPE, and I guess Pivotal to a certain extent. Some of the others, I guess, they're probably based around particular use cases, particular industry cases, maybe clients of these companies as well. But when it comes to each of these sort of offerings, do the providers tend to add something onto it, or do some of them just basically just commercialize it and it remains fairly similar? Is there a lot of differences between the way they implement Cloud Foundry?
Yeah, that's a really good question. A lot of people like to talk about the process of commercializing open source software as being sort of akin to the way that the Linux kernel is commercialized with various distributions. That analogy does not quite work in the case of Cloud Foundry, and let me explain why. So, if you think about what does it mean to be a skilled Linux developer, or a skilled Linux even just systems administrator, it's not really the same thing to say that you know how to just administer Linux if your focus is on let's say the Red Hat family of distributions, right? So Red Hat Enterprise Linux, Fedora, even Atom OS and CentOS. Those skills do translate, but they're not a one-to-one match over to the Debian tree of distributions, whether it's Debian directly or whether it's Ubuntu. There's a lot of differences in the way that those distributions behave and the way that things like package management for software works, et cetera. So we took a look at the model of commercializing and realized one of the most important things that we could do for the end users, right, both the customers as well as the open source users of the Cloud Foundry platform, was to have some level of consistency while allowing for competition in the market. So we created a thing called the Cloud Foundry Certified Platform Program. And what that actually requires is that there's a set of components. In fact, it's the core components of the system that are required to be used in an unmodified form by these downstreams that want to be certified. And in fact, what they need to do is they need to use the coordinated release that the upstream project is producing. And they need to use a relatively recent version of that as well. And each year, kind of the requirements change slightly in order to, move the market along, move everybody along to the latest version of the platform. So what that's done is that's given us a level of consistency across the distributions, but it also leaves a lot of room for differentiation. And so specifically, a great example would be that the backing services that you make available to the developers using the software is a great place to differentiate. So a good example there would be Pivotal is very focused on, for example, they have the Spring development framework for Java developers, and they've built the Spring Cloud suite of functionality that ties to a bunch of backing services that are derived from the Netflix open source, various Netflix open source software, things that support, like Hystrix as an example, right? So it could be very easily tied into a Java developer, and that's a backing service that Pivotal can do. IBM, they have a lot of focus on the Watson cognitive platform, and so they've offered those up as services, right? So there's consistency for a developer's experience, and not just at the API level, but actually behavioral consistency for when they're interacting and pushing applications. But the capabilities that they can tie those apps into are going to vary depending on the distribution. Now, the other thing that does is it starts to open up specific industry vertical platforms. And so I'll just pick one example, which is in the industrial Internet of Things space. So GE Predicts is based on Cloud Foundry, and it has that same experience that you'd have if you were just using IBM Bluemix directly, but it's very focused on the heavy industry use cases that the GE is targeting. Siemens happens to be doing the same thing with the Siemens MindSphere platform, which I think is in a very early release at this point. But they're building up a Cloud Foundry-based IoT platform, and both of those online services are able to support the IoT use cases specifically based on the added functions that they tie in or allow developers to tie into.
Yeah. I think I may have seen some of these demoed. We were actually initially, when you mentioned Bosch, I was thinking you were talking about Bosch with a C, because we saw them. They had an IoT conference here in Berlin, and they were actually pitching their IoT management platform. So for a second, I was thinking that it may be related, but maybe not.
Well, it turns out BOSCH is in fact a Cloud Foundry user.
There you go.
So they're doing quite a lot to make the IT stuff function on
that
top of.
That must get very confusing in their office. So just on that, I mean, so going back a few stages, if a developer in-house in a small tech agency or startup wants to use Cloud Foundry for their infrastructure, can they? And how difficult is that, I guess, and what kind of infrastructure would you need? And also, if someone did want to then take it a step further and commercialize their implementation in a similar way to some of these companies, what would they need to do?
Yeah, that's a great question. So first, when we're talking about a small company or a small team, I usually advise that the best thing to do is to actually find a provider, right? Find somebody who's offering it as a service. Now, if you want something that maybe it's regional to Europe, you could use a company like Swisscom with their application cloud. You get all the capability of Cloud Foundry, but you don't have the overhead of having to manage or operate the platform. You just start developing your application. You take advantage of the services that Swisscom's bringing to market to tie in its backing services, and it lets you focus your time and effort on what's most valuable for your company. Now, if that's not the route that a group wants to take, whether it's a team or a startup or or even a larger enterprise, and you didn't want to go purchase one of the software distributions, you can absolutely go install the upstream Cloud Foundry platform. It is designed as a production grade system, and so it's not we have single VM ways that you can try it, but clearly that's not redundant, right? So what you're really talking about is a distributed system that's going to require a good chunk of virtual infrastructure. Ideally, you do it on a public cloud because that seems to be the fastest way that you'd want to get started, right? We've got great getting started guides for how you bootstrap your environment, and then how you build up, the Cloud Foundry cluster, and then how you manage it, day over day. The last thing you asked was, now let's say that you wanted to offer it as a service, or even create your own software distribution based on the upstream code. That's great as well. So the thing to keep in mind is that the software is licensed using the Apache Software License version 2, extremely permissive. You can do really whatever you want with it. Now, that opens up a lot of possibilities, but we also recommend that companies that choose to do a distribution or choose to do an online service, you probably want to participate in the certification program for a few reasons. One, you get promoted as one of the commercial distributions. But really, two, you also get to call yourself or call your distribution Cloud Foundry, and that's very useful because then someone who knows Cloud Foundry from another vendor will know that they're going to have that consistent experience with you, and that their application is very likely to have no problem running in your service as well.
For sure. Okay, cool. So this conversation comes off the back of OSCON, which I wasn't able to attend in the end. So what were you there? Were you there to announce anything in particular, or just for general conversations and awareness raising, or anything new that you want to make sure people know about?
Yeah, absolutely. So it's two things that I want to make sure people know about. The first is, and we're running out of time for this. We have our big event coming up in our North America version of our event. The Cloud Foundry Summit will be coming up June 13th through 15th in Santa Clara, California. It's an amazing event. We expect to have several thousand people, largely enterprise developers, coming to learn from each other, but also coming to attend these various tracks that have been curated to not just talk about the Cloud Foundry platform and its evolution, but also to focus on some of the language and framework communities that take advantage of Cloud Foundry. So we have a Cloud Native Java track. We have a track dedicated to Node.js applications. Google is sponsoring a track that's going to have a lot of information about how to take advantage of Google's machine learning capabilities, both the open source functions that they offer as well as the Google Cloud services. So it's a place to come and learn. It is not just for those that deploy and operate Cloud Foundry, although we'll have plenty of content for them. It's really about helping the developer who's using Cloud Foundry, or really just generally trying to develop cloud native architectures. We'll have a lot of good knowledge for them. The second thing is that we're at that summit. We'll be moving into our general availability for something that we announced a few months back, which is a Cloud Foundry Certified Developer program, as well as a portfolio of training classes that will be available. So some of them are free, some of them are delivered through a number of different training partners, and we also offer our Cloud Foundry for Developers course online as an e-learning format. The key to the certified developer story is it goes back to the platform consistency across the distributions, because it turns out once you have consistent commercial downstreams that differentiate from each other, but there's consistency between them, then it becomes really attractive to make sure that you can stand out as someone who can prove that through a performance-based exam that really how to build applications and take advantage of the CS platform. So the certification, Cloud Foundry Certified Developers, will allow someone who maybe has taken the class plus a little bit of practical experience, or someone who's just been using Cloud Foundry for a long time, to prove it, and prove it in a way that is verifiable by potential employers. And then also for the employers, there's a lot of systems integrators that do, let's say, application modernization, and they're using Cloud Foundry platform as a way to deploy those apps. They can also use the developer certification as a great way to ensure that their teams are eminently qualified, and to also prove that they've got a team of very strong developers that's being assigned to a particular project.